Confirming to dry. Don't repeat yourself, right? Now people have taken this way too far. Some people plug in an add-on to Visual Studio which prohibits you from using copy-paste. Yeah, they need help. Confirming to dry. Dry means don't repeat yourself. And I won't say that again. No. Okay. We're starting to cheer up, aren't we? The snow is drying. So, do you get it? The snow is drying. No. It means don't repeat yourself. So if I have, for example, code that says, if user is authenticated, do this. If user is authenticated, do this. And I have that in every method call that I have in my service layer. Or I have try, catch, log, try, catch, log, try, catch, log. You're doing dry there. I mean, you're breaking dry there. You're constantly repeating the same code over and over and over again. And that's not solved by using code snippets or templates or anything like that. You don't have to write that code. Those things can be solved in different ways. One of those ways is called aspect-oriented programming, which is taking class. Each class has a single responsibility. However, there are things that are cross-cutting across multiple classes. For example, logging, authentication, etc. You can solve those problems with AOP. And I won't go deeper into that because Jonathan will then talk to you about AOP later in the day. Tightly coupled classes and strong dependencies. Okay? So let me show you some code. Creating a new ASP.NET MVC application, and I will create a unit test. How many of you work with ASP.NET MVC? The templates that ship in the box are a great example of how you should not do things. Okay? One of the things is the account model, right? After partial classes, what's the worst thing that you can ever find as a software developer working in C# or VB? Regions. Regions are pure evil, right? Why? Because all they're doing is hiding our smells. Our code smells here. I have, in ASP.NET, I have a folder which is called models. Models is about models. In terms of MVC, they're called view models, mostly. Okay? So inside view models, they ship out of the box a file called account models. Notice the word models in there. Inside that file, they have models, but they also have services and validation. Right? So why would I put two classes in one file? That's an anti-pattern. Why should I do that? Just so you see. Take that class. I'll take the actual project. What this is going to do is go through it and separate all classes and put each one into its own file. Right? Look how many classes have emerged. Account membership services, account validation, change password models, forms authentication, iMembership services, log-on model, register model. So in actual fact, there's only 2 models in there. 3. The rest aren't even models. But we'll ship it in the box. And then when people will look at it and they'll say, well, if Microsoft does it, it's okay. And it's completely wrong. Why? Was it, if we had added a new folder to this template that said services, would it scare us? Would we think that ASP.NET MVC is too frightening because it has a folder called services? Well, of course, you know why they say they won't add that. And I'm just assuming this. They'll say, well, no, you see, services shouldn't be part of the web application project. They should be outside. But it's there. You're just hiding it with a region. And in fact, these services are fine being, well, yeah, these services are okay to be there. So, lessons learned. Don't use Microsoft as an example of how to do things right. So here I have a method, a test method, okay? Every unit test is composed of three parts: arrange, act, and assert. The arrange sets up an environment, the act takes an action, and the assert verifies that what has happened is correct. I have a home controller, I create an instance of it, I call the method index, and that returns to me a result, and I validate to see if it's returning the right result. Let's say that I take that home controller now over here, inside here, and what I will do is say, you know what, it's not going to return a result for me, it's going to return a list of customers. Okay? So when I want to return a list of customers, I say customer repository, equals new customer repository. Right? I'll create that. And then I'll do var customers equals customer repository get all. Okay? Done. No, not done. I list customer. We're done. Okay, and now I'll pass this over to the customers. Run that. Come back to my test. Run it. What have I just caused? Now, when I run my test, what do I have to have? A customer repository, right? Which normally means I'm talking to a database. Which normally means I need to now have a database set up to run my test. Which is okay. I can set up a temp database, run my test. But as I add more tests, my database grows. As my team worker adds more tests, he'll change the data. And then suddenly my list of customers is deleted because he needed to delete customers in some test. So now my test failed for the completely wrong reason. Right? But not only that, now my tests start to go slower as well. Why? Because I've got a big clunky database. And now let's add more services to it. Let's talk to a web service. Let's talk to some SOAP server. Let's talk to an RSS feed. Now I've got all these external dependencies that somehow I need to talk to every time I run a test. Take this and blow it up to bigger proportions, and that's exactly the same problem we have when we're doing RAD development with line of business applications and drag and drop. There is such tight coupling between each component of the system, it's hard to test. If a unit test is about testing one thing and one thing alone, right now, if this test fails, it can fail because my logic in that call is bad, because the code in my code repository is bad, because my database has failed, because my username or password is invalid. It can fail for multiple reasons. If we're writing unit tests, it's to gain time. It's not for us to be debugging unit tests. If you're debugging unit tests, you're doing it wrong. Okay? It means you've got too much code in your unit tests. A unit test should be pass or fail. Fail tells you exactly where it's failed. One of the advantages to doing unit testing is that we spend less time debugging. So if we're debugging our unit tests, it's not working. This is because of the external dependencies, which is called tight coupling, because this home controller is tightly coupled to my repository. So now every time I want to test this, I've got to set up a database, and I don't want to do that. How do you solve that problem? It's actually very, very simple. Instead of me creating a repository here, what I can do is just pass it in. So I'll create a field called customer repository and pass it into the constructor. That's it. What benefit have I gained there? Well, now I have control over the customer repository. What does that mean? If I go back to my test, I can now say, instead of passing in a customer repository, I can pass in a what? A customer repository, no? Or a descendant of it. So we've got to do one more thing, which is what? We've got to extract an interface on this. Right? And now, Because what? There is this principle that says program to an interface on a class. So now, I use an iCustomer repository. Which means that in my home controller test, I can now pass in anything that implements an iCustomer repository, including a fake customer repository. So I can now come here and say, new fake repo, create the class, implement the members, return list of customers. Done. So now I've eliminated the external dependency, which is my database. And what I have actually obtained is loose coupling between my classes. Now my home controller doesn't depend tightly to a specific class of customer repository, but it passes in an interface. So I can now define or change the behavior without touching my home controller. If tomorrow I want to change the behavior not only because of my tests, but because I want to implement a different version of a customer repository, I can do that without touching that code. Which means the less code we touch, the less chances of breaking things. I won't go more into this because Mark will cover this in his talk a little bit later. But that is what's called the dependency inversion principle. And that's the D in solid. So I've shown you these things, and now of course you don't go buy the book, which don't ever buy that book first. It's very boring to read. There's a better one which is called Head First Design Patterns, which is much more interesting because it explains to you the problem better. It's always valuable when you say something to someone, tell them why they should do it, not that they should do it. Give them an example of why it's bad if you don't do it. And Head First does a good job of that. Okay? That doesn't mean now when you go and start to program, you use every pattern that's in the book. That's called the anti-patterns of patterns. Is now everything I do, I'm going to try and merge it into a pattern. And the same goes with the principles. There are some principles that aren't easy to follow. One of them is the open-close principle, the O in solid, which says a class should be open for extension but closed for change, which sounds kind of like an oxymoron. How can I have a class that's open for extension but closed to change? Right? That's actually solved with things like polymorphism. But the open-close principle is sometimes extremely hard to comply with. However, you need to know the principle. You need to know when you break it. And what's more important, you need to test when you break it. Every time I have broken the open-close principle in my code, I have written a specific test that will fail if I add some code that would break that principle. So if I, for example, let's say that I have some code that checks on the type system, and at some point I have to do if type system equals this, or if controller is that, if controller is this, if controller is that, do this, do this, do that. You can add a test that says, scan all the assemblies of scan all the controllers in my assembly, and make sure that each of these controllers can call this method, and there won't be a uncaptured controller type exception thrown. It's important to try and capture those because OCP will bite you. Okay? So, going back to our brownfield, we'll always be in brownfield. It's just a matter of taking that and trying making it a little bit better to be more comprehensible, maintainable, and easier. And that doesn't come by applying principles alone. It comes with other things as well. It comes with testing. So hopefully, next, when we show some more about testing, and I'll show you some added value to other than just validating that your function is working, we'll be doing more unit testing as well. Okay?